Today's cameras are more than capable of recording high-quality video internally. However, there are times and places where it's necessary, or at least advantageous, to just use the camera to convert light into a video signal and then process that video data somewhere else. That other device could be something like a monitor recorder, like this Atomos Ninja, a capture card in your computer for streaming, or even dedicated streaming hardware that's made by companies like LiveView for journalists who work with out in the field. Even if you're not recording the HDMI signal, just using it externally to power a large display for better monitoring, how the HDMI output is configured on your camera will affect the quality and correctness of the image you get on that monitor as well. So in this video, we are going to look at the settings that affect how the HDMI port carries standard video signals. Well, what I mean by that is we're not going to be talking about HDMI raw today, and how those settings affect external recorders and monitors and anything that you might have the camera hooked up to. And also, before I get started, I want to mention this. HDMI is a complex closed protocol. Detailed information about how it works is not publicly available. And of course, decoding the HDMI signals themselves, which is reasonably feasible or entirely possible. It's not like you need the standard to understand what is on the wire, at least as long as it's not encrypted, does require expensive test equipment that I don't own. Now, the reason I'm raising this point is because exactly what is on the wire, the image quality, colored bit sample, subsampling depth, bit depth, etc., all depends not only on the compatibility or capabilities of your camera, but of the capabilities of both devices on the HDMI connection, so the transmitting and receiving end. What this means is that while your camera may be perfectly capable of sending 4K, 60 frame per second, 10-bit 422 chroma subsampled video to your monitor or recorder, if your monitor or recorder can't accept that, then the two will negotiate down to a lower quality instead. And of course, without more detailed information about what's going on at the physical level, it's very difficult, if not impossible, to talk about what exactly is going to happen. So everything that I'm talking about in this video should be taken as a up to, not necessarily a guarantee of what you're going to get. Finally, log gamma curves and wide gamut, or specifically camera-specific cinema color gamuts, are not part of the HDMI video standards. As a result, there is no metadata available to downstream devices to ensure that they understand what gamma curve or color space the signal is in. Instead, you have to know, or at least have notes of what is being sent or what the camera was configured to send, since you don't have metadata to do that for you down the road. Now, with that in mind, there are some limitations that come with using the HDMI port on Canon's R5 and other similar era cameras. First, the maximum resolution and frame rate the camera is capable of sending is 4K at 60 frames per second. Now, video will all still be output when the camera is configured to use a higher frame rate, 120 frames per second, but the output will be limited to 60 frames per second, or 50 frames per second if you're in a PAL region. In the event that your recorder does not support 4K 60, the camera will deliver 1080p 60 instead. In other words, the camera favors frame rate over resolution when your recorder can't deal with the higher frame rate at the higher resolution. Secondly, the HDMI frame rate doesn't always depend on the selected resolution and frame rate that you choose in the camera for recording settings. I will come back to this in a moment when I cover those settings in detail, but that's something to be aware of. Third is the question of image quality. That is, what chroma subsampling, bit depth, and output signal range are being used by the camera when it's transmitting. Now, my understanding is that the Canon camera's output tries to match the internal recording's chroma subsampling and bit depth. What this means on the R5 is that with Canon log or HDR-PQ, the HDMI port should be giving you a 10-bit 422 chroma subsampled image, while if those are off and you're just in the standard recording mode, you should be getting an 8-bit 420 color image. Further, as far as I can tell, Canon always outputs full range signals instead of the smaller broadcast or legal range. Now, finally, the R5 has an issue. It does not output color data in Canon's Cinema Gamut. This means that if you select log 3 and Cinema Gamut for your color settings or your image recording settings, the HDMI output will actually be in BT 2020 color instead. I'll talk about this more in a bit. Now, once you've decided you're going to record externally, there are a few settings that affect the output. So let's talk about those. I want to start with the movie record size setting found on page 1 of the red shooting menu. Now, I would hope if you've been using any of these cameras for any length of time that this is going to be very familiar with you, or you're going to be very familiar with this, as it's basically where you go to change image size and frame rate. Now, the two relevant settings in this menu are resolution and frame rate, as these affect both the internal recording's resolution and frame rate, obviously, as well as the HDMI output. Now, there are a couple of gotchas that you need to know here, though. First, when recording, or when the camera is set to full HD or 1080p recording, the HDMI port is always run at either 50 or 60 frames per second, depending on whether you're using PAL or NTSC system modes, respectively. And this happens regardless of the selected frame rate that you have in the camera. So if you want to shoot at, say, 24 frames per second, select that frame rate and then use an appropriate shutter speed in the camera for that. Now, your output is still going to be at 60 frames per second, but the camera will duplicate frames as necessary to match the higher frame rate on the output. Now, with that said, these files can be dropped into a timeline with an appropriate slower frame rate, and your NLE should take care of dropping the duplicated frames for you. Now, the consequence of this, however, is that if you cannot set your recorder's recording frame rate independent of its HDMI inputs, this is the case for recorders from like Atomos, you will be forced to record at the higher frame rate and consequently higher bit rates, but you aren't going to get an improvement in quality because you're just going to have duplicate frames. Second, when 8K resolution is selected, the HDMI output will only be at 4K with the matching sensor aspect ratio, so either 16:9 in UHD or 17:9 in DCI. Now, this brings us to a very important question about resolution versus image quality. On the R5, there are 3 configurations that will result in 4K HDMI output: standard 4K mode, 4K high quality mode, which is 8K downsampled to a 4K recording internally, and 8K. Now, in my testing, I found that the HDMI image quality was identical between the 4K HQ recording option, or having that enabled, so that's the internal downsampled 4K mode, or putting the camera in 8K resolution and just going with that. In either case, the HDMI port signal is downsampled from the full 8K frame. Now, when you shoot in standard quality 4K mode, the camera line skips. Of course, this is done to decrease the temperature load, processing load, and increase rolling shutter performance. But of course, it does hurt image quality since we are reading all of the sensor data. However, because this is happening at the sensor and not somewhere down the image pipeline, the HDMI image will also be compromised in the same way your internal recordings would be if you were working in this mode. Now, consequently, if you're only worried about external recording, I have found that the easiest way to maximize image quality is just to switch the camera into 8K resolution mode instead of enabling 4K high quality for those recordings. Again, if you're only worried about the HDMI output. Now, of course, if you need the faster rolling shutter performance or 60 frames per second, then you have to use the standard 4K quality recording mode and accept the image quality compromises that come with it, whether you're recording internally or on HDMI. Next is the HDMI resolution setting, and this is found on page 4 of the yellow setup menu. Here you will find two options, auto and 1080p. When this is set to auto, the camera uses the highest resolution that it can negotiate with your external recording device. To put this another way, if you've selected 4K UHD or 4KU in your movie record size menu, then the HDMI port can output at up to 3840 by 2160 resolution. However, since the HDMI system negotiates the actual resolution that will be used based on what both devices support, the actual resolution may be 1080p or potentially even lower depending on what your client or recording or monitoring device actually supports. Now, be aware, if you are trying to output 4K 60 frame per second content and your receiving device cannot support that frame rate, the camera will lower the resolution, not the frame rate. So the port will output at 1080p 60, not 4K 30. So you will get a lower resolution, equal frame rate, not a lower frame rate at the equal resolution. Now, on the other hand, the option is to choose 1080p, and this limits the HDMI port to only outputting at 1080p resolution. Now, the advantage of this is that the HDMI signals won't change resolution when the camera's resolution changes internally. However, this shouldn't happen in most cases when you're actually recording or trying to stream or something like that. It would only typically happen if you tried to go into the menus. Now, if you are doing external recording, you will want to keep this setting set to auto to get the highest resolutions that you possibly can and have the resolution match what you've set the camera to. Now, the next setting of relevance is also the HDMI display setting. You will find this on page 8 of the red shooting menu when in video mode. An HDMI display has two options, and these are both expressed by icons. First is the camera plus external monitor setting. This sends the camera's video to both the internal displays and the HDMI port. The camera's display retains information overlays and assistant functions, like zebra stripes and focus peaking and what exposure settings are, while the HDMI signal will be a clean recordable file or signal. However, the camera's menus and playback output are sent to the HDMI port, not the camera's display. So going into the menu to change settings will show up on the HDMI output, not internally. The second option is external monitor only. And in this mode, the HDMI port receives video, and it's the only thing that gets a signal. In order to get a clean signal in this mode, you have to press the info button until you get to a screen that has no overlaid information displayed. Now, that said, be aware that when using the external monitor only function, even with a clean display, shooting information and assistance functions can and will be overlaid. Moreover, assistance function visibility, which you can actually see and which you won't be able to, varies from what is the case with the internal displays. So, for example, zebra stripes are rendered on the HDMI output just fine, even if the other overlays are disabled, like the shooting information. But focus peaking is not rendered on the HDMI output regardless. Now, for external recording, the recommendation is to set this to camera plus external monitor, and then go into the auto power off setting over in the settings menu and set that to disabled. In this configuration, you will get a clean HDMI signature, while the exposure and focusing overlays will be available on the camera when you need them. Moreover, because the auto power is turned off, the HDMI port will remain active as long as the camera is on and not overheating, even if the display on the camera itself turns off. Now, in addition to the HDMI display mode, another setting that's critical to external recording is the standby low-res setting. This is found on page 8 of the red shooting menu, again in video mode. This setting controls whether the camera always reads the sensor at the selected recording resolution and frame rate, or if it will reduce how it reads the sensor when the camera isn't actually recording to save power and heat. Now, when I say recording or not recording, I'm talking about the internal recording. Now, for external recording, since the camera is always in standby mode as it perceives itself, you will want to disable this to ensure that the sensor is always being read at the selected resolution and quality, and you get the best quality signal at your device on the outside. So while that covers the settings that are most directly related to controlling the HDMI output and the resulting recordings, the HDMI output itself isn't separated from the camera's standard image processing. It's just an output. That is, the HDMI output will try to match the color and gamma curves that are selected internally. And I say try because there is that exception I mentioned at the beginning. The problem here is that when the camera is set to use the log3 gamma curve, in that case, only BT709 and BT2020 color spaces can be output on the HDMI output. If you choose Cinema Gamut, the HDMI signal will be in Rec 2020 instead. Now, technically speaking, you're not really losing much here. In my opinion, at least, Canon Cinema Gamut is a little bit problematic from the design perspective. The blue and green primaries are imaginary colors, and they're so far outside the visual range that only about 50% of the actual values or code points that can be used to express color can actually store real colors or effectively be used. Now, conversely, while BT2020 doesn't cover as large of a gamut as the Cinema Gamut does, it doesn't use imaginary primaries, and therefore the entire 10-bit color space or coding points in that color space can actually be used to store information. Now, in practice, this probably really doesn't matter that much. And in fact, even Netflix camera configuration guide for their own productions specifies shooting in the Cinema Gamut. However, what this does mean is that the BT2020 recordings that you're going to get from your HDMI output can more precisely represent specific colors, which in turn can create problems in color matching between an HDMI recording and a Cinema Gamut internal recording in a very, very demanding color grading environment. Quite honestly, though, the bigger problem, at least as I see it, is more logistical. That is, you're always going to have to know which files need which LUTs or color space transforms based on whether it was recorded internally or recorded externally. And if it was recorded externally, is it from an R5 or an R5 Mark II or an R5C or something else? Because this issue isn't a factor on the R5C, for example, or the R5 II for that matter. And of course, complicating things is that since there is no metadata for any of this information, you have to make those notes manually and remember to keep them. So that covers the HDMI specific output settings and what you need to know to effectively record the HDMI signal. But the worst problem really is that whole log3 color space issue, and quite honestly, that's easy enough to work around, at least if you're aware that it is a problem. That said, I hope you found this useful, or at least interesting. If you did, let me know by hitting that like button. Also, if this kind of thing seems like it might be your kind of thing, please consider subscribing if you haven't already. Finally, if you'd like to help and support this channel, you can help us for free by liking this video, sharing it with your friends, and leaving a comment with your experiences. Likewise, you can support us by hitting that thanks button or buying yourself something you've always wanted from one of the affiliate links in the description below. And as always, thanks for watching, and I'll see you next time.